Welcome to iBlastX. iBlastX is an innovative, easy-to-install system that allows you, the mine, to track and log critical information. Here is a view of the integrated system. Import your blast data to the iBlastX cloud so that your information is exactly where you need it, on the bench. To start, export your blast design from your blast design software. This should be in a CSV format. Once this is completed, simply access the BlastX website and select the Import Pattern functionality located under Setup. Next, simply drag and drop your files into the allocated area. Once your data has been imported, you will be able to view every hole displayed on a map. From here, you will be able to evaluate each data point and access crucial information about each hole. Here, we have the iBlastX operator application. All of the shop design data has been imported and is readily available. Now we will demonstrate the iBlastX software in a typical workflow from the bench. The iBlastX application will track the operator's current position and automatically complete the pattern number. For instance, this pattern number is 20178. The operator can manually enter the hole number as well as other important information such as height and decking. In this example, the operator is at hole 101. Alternatively, the operator can use GPS tracking and the previously imported design data to access hole information more effectively. They can also use the GPS to track their position in regards to hole locations in real time. In this example, the operator has selected hole 101 from the interface. As you can see, all of the information has been automatically filled in. From here, the operator has all of the information that is needed, such as depth, stemming, and how many kilograms of product needs to be pumped into the hole. They will also be able to input any additional information, such as if the hole is wet or collapsed. There is also a free text field that can be used for more specific information about the hole. Once all of the data is filled in, simply press Start, and all of the information will automatically be sent via Bluetooth to the data logging box, which is also installed on the truck. Now the hole is ready to be pumped. Once the hole is finished being pumped, simply press Done. Now that the hole is finished and all of the information is logged, the operator can move on to the next hole. In this example, the operator has completed hole 101 and can now move to hole 102. As you can see, this hole is actually a multi-deck hole. The interface recognizes this and allows you to select the deck number, and from there, all of the necessary information will automatically be filled in. As you can see here, the previous hole's history is shown, so it is easy to keep track of your work. The iBlastX application is customizable to any language. Here the application is running in French. iBlastX also supports metric or imperial units. Once the truck arrives to an approved hotspot, all of the information collected on the bench will be automatically uploaded to the secure iBlastX cloud. The iBlastX website is the best place to visualize your as-loaded data. So far, we covered how your design data can be uploaded to the iBlastX cloud, which is transferred to an operator who uses the iBlastX operator application on the bench in conjunction with the logging box to collect the as-loaded data. From there, the as-loaded data is transferred back to the cloud via Wi-Fi and is now ready to be analyzed. The iBlastX software was designed to be intuitive and easy to use so that you can focus on what's important, the data, which thanks to the visual interface makes it very easy to quickly identify outliers in your data. Let's take a look at some of the data to see how iBlastX works. First, we need to choose a pattern. In this example, we are taking a look at the highlighted pattern. The first table you will notice will be the daily summary. Here, you will be able to see important information such as date, which vehicle was used, the number of holes that were pumped, the duration, and the weight used. For example, on the 11th of March, Test Truck 3 pumped 28 holes for a duration of about an hour and used 76,249 pounds of product. This information is useful because it allows you to reconcile it against your weighbridge data, and it also checks to see if the pumps are calibrated correctly. The second table houses all of the information that was collected from the operator application and the data logging box, and each hole displays all of the necessary information. Select a hole from the table to get a visual representation of the hole loaded information. The green section is the design column. The red section is the stemming, and the yellow section represents the degree of overload or underload. As you can see, in this case, the hole was filled perfectly. Now, let's take a look at a hole that was significantly overloaded. As you can see from the design data, this hole was significantly overloaded. The yellow column greatly exceeds its ideal stopping position. If we scroll down, we will find a map with a visual overlay of the as-loaded data. If you hover over a hole, you will be shown all of the data collected for that specific hole. The holes are ranked by color to easily see which holes are good to go and which needs attention. The green holes are well done according to the data, whereas the orange holes have at least one problem with them, and the red holes have multiple problems. Wet holes are represented by a blue dot in this overlay. Because the design data has been imported, we are able to overlay the expected design on top of the as-loaded information by clicking Design. If we zoom in, we can take a closer look at the overlay. The dots are the as-loaded information, and the red crosses represent the design information. In this example, it seems as if 1,870 pounds of product was supposed to be pumped and 1,877 pounds was actually pumped. You can also click on the Overfill overlay to easily see which holes were overloaded and which ones were not. The larger the circle, the more that hole was overloaded. If we find a smaller circle, such as this one, you can see that it was overloaded by roughly 250 pounds, whereas if we go to a larger circle like this one, we can see that 5,192 pounds went into the hole, but it was only designed for 1,779 pounds. We can see a summary of the pattern by scrolling up to Recent Patterns. This gives a summary of all of the important information. As you can see, 318,212 pounds were actually loaded, whereas the design called for 294,449 pounds, which means it was overloaded by 23,763 pounds, or 8%. You can also see how many holes were designed to be filled versus how many holes were actually filled. In this example, you can see that 141 out of 144 holes were filled. You were able to view this on the map to find out which holes were not filled. You can see 3 holes over here were not filled because there is no loaded information. Just below the map, you will find the timeline. This represents how this pattern was filled over time. If we hover over a part of the timeline, a dot that shows which hole was filled will appear. It also tells us which truck was responsible and at what time the hole was filled. As you can see, we can scroll through the timeline and the overlay will show us the order of the holes in which the pattern was completed. The other benefit to this overlay is the fact that it makes it very easy to visualize the sequence of loading. You can easily see when the trucks were filling and when they were not. In this example, you can see that truck 2 was busy until 10:48, and then nothing happened until 11:41. There could be a number of reasons this happened, but thanks to the timeline, you are now aware that nothing was happening at that point in time. This information is readily available and can help you improve productivity significantly. One more useful feature is the Load Progress Overlay. The Load Progress Overlay will indicate which holes were loaded on a particular day. Each different day that the pattern was being loaded will be indicated by a different color. When shots sleep over an extended period, this overlay becomes very useful in organizing and using the data that was retrieved.